right, here's your video for your Unit 9 quiz review. These first two we're just going to convert. I made them this way on your quiz as well. I made them both end up on the axes. So you can just draw a picture if you want to get a visual of this. Or if you don't even need a picture, then that's fine too. So we're going to rotate to pi, which would be over here. But we want to go 3 in the opposite direction. So that's going to put us right here. And so your answer is 3, 0 in rectangular. This one's already in rectangular. 0, negative 5 would be down here. Again, if you don't need to draw a picture, that's fine. In polar, we would want to rotate to 3 pi over 2 and go 5 units in that direction. There are an infinite number of answers for this question, though. For example, you could do 5 comma negative pi over 2 if you wanted to rotate backwards. You could do negative 5 comma pi over 2. Pi over 2 would put you up here if you go 5 in the opposite direction. So this could have an infinite number of answers, but this is, I think, the easiest way to do it. All right, for this one, we're going to make a table. I'm going to start with 0 pi. I know this is going to be one of my rose curves with 3 petals. If this number is odd, you get that many petals. So if it's 3, you get 3. If it's 5, you get 5, etc. If it's even, you get double that many petals. So if it's 2, you get 4. So I know I'm going to end up with 3 petals. Sine of 0 is 0, so the whole thing is going to just be 0. Now you can pick whatever you want, but you want to pick something from the unit circle and also something that's going to turn out nice. So I'm going to do pi over 6 because when I plug that in, I'm going to get 3/6, which is 1/2, or it's going to be pi over 2. Pi over 2 is at the top of your unit circle. Sine of pi over 2 is 1 times 2 is 2. I'm going to choose to do pi over 3 because when I plug that in, the 3's will cancel. So again, you want to pick values from the unit circle that are going to turn out nice. So 3's cancel, you get sine of pi, which is 0. All right, then I'm going to do pi over 2. If I plug in pi over 2, I'm immediately going to get 3 pi over 2, which is at the bottom of my unit circle. Sine would be negative 1 times 2 would be negative 2. And I'm going to keep on going here with my thirds and my sixths. Oops, I didn't mean to write that. I said thirds in my hand over 3. I want to do 2 pi over 3. So if I plug that in, the 3's are going to cancel. I would just get 2 pi. Sine of 2 pi is 0. I kind of ran out of space, so I'm going to continue my table over here. I'm going to do my next sixth here, 5 pi over 6. If I plug that in, 3/6 would reduce to 1/2. It's going to be 5 halves. 5 halves is going to be in the same place as 1/2, pi over 2. So this is 1/2, 2 halves, 3 halves. 4 halves is 2 whole pi. That's the whole way around. 5 halves is going to be up here. So sine of that would be 1 times 2 is 2. And then I think that's enough. I think I've gotten through 3 petals there, so we can go ahead and draw this in here. So pi over 6, we have 2 units from the pole. Pi over 3 is back to 0. Pi over 2 is negative 2. That's going to put me down here. Then back to the pole again. And then 5/6 is going to be at 2. So I'm going to start here, come around, go back through the origin, and it will look like that. It's not perfectly symmetric because I'm not an amazing artist. These should all technically be the same size, but good enough. I can show that there are 3 petals and all my points are in the right place. All right, find the derivative dy dx for this. So x is r cosine theta. Now this is secant squared. I'm going to write it as secant times secant. You'll see why in a second. So that's r, secant squared, times cosine theta. And then y is r sine theta. There's nothing I can do to clean this up, so I just kind of left it alone. This one, though, secant and cosine are reciprocals. You can think of rewriting secant as 1 over cosine, but these are going to cancel, and so it's just secant theta. And so if you notice something like that, it makes your life a little easier because it's a lot simpler to work with. All right, so dy dx. And just to bring this up, because this is the exact same thing that you did with your parametric equations, except you have theta in there. Make sure y goes on the numerator and x goes on the denominator. It's dy dx. On the quiz, a bunch of you had it reversed, and you're just going to be upset if you do the same thing again. So here we go. Product rule. It's going to be first times derivative of the second. Derivative of sine is cosine plus the second times derivative of the first. Now, this is a chain rule. The 2 is going to come down. It's going to drop to a 1. You can write it if you want to. And then you have to chain on the derivative of secant, which is secant tangent. So that took up like the whole paper. There was a product rule and then a chain rule inside of the product rule. But this one's going to be easier because all of this is gone. Dx d theta, derivative of secant is simply secant tangent. And you don't have to clean that up. You can just leave it alone. I'm going to kind of let that sit there for a second so you can see it. It was first derivative of the second plus second, and then this whole thing is derivative of the first because there was a chain rule. All right, this one's the exact same thing, except we're actually going to plug in a value, and it says to simplify completely. I'm checking that you know your unit circle. It says slope of the tangent line. That means dy dx. So x is going to be r cosine theta, and y is going to be r sine theta. So our dy dx, we're going to do derivative of y first. This goes in the numerator, right? Again, it's a product rule. So first, derivative of the second plus second derivative of the first. 3 is going to be gone since that's a constant. Derivative of cosine is negative sine. This is a little bit of writing, but it's not necessarily hard. I mean, you know your derivative rules, right? And then same thing for this one. It's going to be almost the same. All right, so first times derivative of the second, it's negative sine, plus second times derivative of the first, again, is going to be negative sine theta. And then we're going to plug in 3 pi over 2. Technically, I can't write today. Let me use my whiteout. That doesn't look pretty. Also, I have trouble writing because the projector is right above my hand and I'm trying to not bump it. So it's dy dx such that theta equals 3 pi over 2. That is what we are finding. What you don't want to do is like put an equal sign after this and start plugging it in. That's called a linkage error. You're linking together two things that are not equal. They will not give you credit on the AP exam. So 3 pi over 2 is at the bottom of your unit circle. It would be the point 0, negative 1. So cosine of that is going to be 0. So actually, that entire thing is going to go to 0. If this is 0, it doesn't really matter what that is. So 0 plus sine of 3 pi over 2 would be negative 1. So we would have negative 1 times positive 1, because those negatives will cancel, so negative 1. All right, and then in the denominator, again, cosine of 3 pi over 2 is going to be 0, plus 3 would be 3. Sine of 3 pi over 2 is negative 1, but the negatives cancel, so that'll just be 1. So actually that whole thing will just be 3. And then again, cosine of 3 pi over 2 is 0. So negative 1/3 is our final answer. It says simplify completely. So pretend like it was multiple choice. Your answer choices aren't going to look like this. They're going to have you simplify it. All right, and then last one, at what values of theta does r equals cosine theta have a horizontal tangent line? Horizontal means dy d theta equals 0. If it said vertical, it would be dx d theta equals 0. And again, that is the exact same thing we did with parametric equations. It's just instead of dt, it's d theta, and you have unit circle. Right? So let's find y. Y equals r, just cosine theta, sine theta. It's r sine theta. So cosine theta, sine theta. So dy d theta, product rule. First times derivative of the second plus the second times derivative of the first. And we're going to set this equal to 0 and then solve it. So cosine times cosine is cosine squared. This is going to be minus sine squared equals 0. I'm going to add over the sine squared. And then to get rid of the squareds, we're going to square root. But when you square root, you get plus and minus. So what you have to do to get your answers is think about on your unit circle where sine and cosine are equal. That's going to be your pi over 4 angles on your unit circle, where they are equal, but the sign doesn't matter. So that would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, except I think we had yeah, we're going to stop at pi. If you were going the whole way around to 2 pi, again, it would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. But because of our interval, we're going to just stop there.